All right, so today is going to be a little bit of a catch-up day. Because I haven't seen you guys in 2 weeks, I'm going to make sure that everybody's kind of on the same page. I assume that everybody has watched the lectures about the different scientists, but today we'll be able to find that out for sure. And so if you haven't, this is kind of some space I carved out to making sure that everybody's watched their lectures. And then I'm going to go through the grade book, make sure that everybody has done all of their lectures and things like that. Okay, but so what I want you guys to do, there's 3 main things you guys are going to work on. The first thing I want you to work on is these are the scientists that we pulled out that we think are particularly important. So you can either use your notes or you cannot use your notes, but I would like to know if you can tell me what each of these people did, and they are in chronological order for you right now. I'm not going to guarantee it'll be that way on the quiz. And then the quantum mechanics portion is at the bottom. The newer scientists are at the bottom. They don't have a model because we're working in the quantum mechanic model. But go ahead and tell me how the model has kind of changed over time with these scientists here. Another thing you guys can work on today is in your packet, there's atomic structure worksheet number 3. You will see another chart like this on the test on Friday, so it never hurts to do some of this. And I'll put this key in the folder. Actually, I don't think I have it there yet, but I'll do that just as soon as we quit talking like this. And then the last thing, you kind of have to go backwards, okay? And this shouldn't say Thursday. This is what I normally do with this, and we would have usually done this earlier in the year. So if you'll take your packet for me and kind of go back, it's almost at the very beginning. So we never did this paper. It says names and element symbols to know. I would like at the very least if you just fill this out. Okay, the number one reason why is because people are like, oh my God, I totally know that C is calcium, so that's fine. But no, C is carbon. Okay, so there's a lot that people think that they know and things like that. We usually do this at the beginning of the unit to kind of help you along. But the other thing that we usually do is we usually give a mini quiz, and the group, the period that gets the most perfects will get extra credit for everybody. So we hadn't exactly figured out how to give a quiz. So we are thinking that sometime in the new year, and it's not like it won't be like a pop quiz or anything, but to give you time starting now, sometime in the new year, we're going to give everybody physically like it'll be a paper and pencil test where we might give you 10 symbols, and you have to say, you know, AU is gold and O is oxygen. And then you would have to also give me symbols like manganese is Mn and fluorine is F. Okay, so the third thing I want you guys to work on today is I would like for you to at least fill this in. And then on your tray, and so again, you're just looking it up off the periodic table. It should be very simple to do, but you're saying C is for carbon. K is for potassium. Very good. And so some of them are a little bit more challenging. Again, my apologies, we didn't do it earlier. We were just trying to figure out a way to get an in-person quiz, and then we were away for so long, and I don't know. So those 3 things is what I would work on right now. Once you kind of feel good, I would absolutely, you have to finish this whole paper, okay? I will go over this at the end of the period. Like I said, you can do atomic structure number 3. If you're feeling it, do some of it. That you'll see that on the quiz. And then get into these. I also have put 10 flashcards on your table with a pair of scissors. Cut them in half again, and that will get you 40 cards if you would like to make flashcards of these names and symbols, okay? And usually I'd give you like colored pencils and markers, and it would be fun, but scissors is all I can sanitize between the classes. So, and there should be a paper clip on there so you can then keep them together. So today is going to turn into a little bit of a work day. I want to walk around, see how you guys are all feeling, make sure that everybody has done all of their lectures. Okay, and I'm going to check with people at home and then maybe give them the freedom to go and do whatever they want to do at their own pace. Because like I said, yesterday was the last day for learning new content. You know everything you need to know now. And then tomorrow when we meet, I'll tell you exactly what the quiz looks like and all that kind of good stuff. So we're finalizing it right now. We're going to meet after school to put the final touch on it. Okay, so 3 things. Work on the history of the atom. maybe challenge yourself first to try to answer it without your notes, then go back in and flesh it out with the notes. Then I would make sure you finish your list of the elements. Make sure you know all the element symbols and the names. And then if you would like to hit a few of these, I'll put this key in here right now. Okay? All right. Good stuff. Let's do that. All right. I'm going to check in really fast with you. Okay. All right. As long as I'm sure that everybody's gotten their scientist portion done, I will go over that a little bit with you guys and then give you some time to do lecture questions and make your flashcards and do all that kind of good stuff. So let's get into this, shall we? So these are the scientists we thought were particularly important, but anything on the review sheet is really fair game. We wrote the quiz off of the review sheet, so you want to make sure you know what you're doing here. Democritus, what was his claim to fame? Talk to me. Perfect. He had the first idea that atoms even exist. Now, the tricky question here is, does he have a model? No. Okay. No model, no nothing. Aristotle didn't believe him, set us back a couple thousand years, you know, just tiny mistakes. But so again, we call them atoms because of his work. He believed that everything was made of indivisible little pieces and parts, and he was pretty darn close to being correct for what kind of technology he had at the time. Dalton, because in between Democritus and Dalton, we had two people that were showing us evidence of atoms. That was Proust and Lavoisier. Lavoisier wrote the law of conservation of mass, and Proust wrote the law of definite proportions, right? And then we finally get to somebody telling us that atoms exist, and that is Dalton. He wrote the atomic theory, that atoms are indivisible and indestructible. Atoms of the same element are the same. Atoms of different elements are different. And that every compound is made of a definite proportion of atoms, which is a lot of the work that other people had already done, right? Now, Dalton was the first person to think that atoms absolutely exist. So they asked him what he thought it looked like and what was Dalton's model of the atom. Simply a marble. It had no pieces, no parts. Okay, it was just a sphere. Awesome. Then Thomson came along and found the first part of the atom. What did he find? What did Thomson find? Talk to me.
Electron.
He found the electron. And he found with the cathode ray tube these electrons that can come out of the atom. So if there's something negative, there also has to be something positive. So he figured that much, and he thought he must have been hungry on this day. We found a piece and part, and now he thought the model of the atom looked like plum pudding. You got it. There were positive plums, if you will, or positive pudding with negative plums in it. And again, the pictures will be way better on the quiz, on the test on Friday. So Rutherford came along, and I would know Rutherford's experiment. His was the most important. He basically fired bullets at this plum pudding, and he hit something that they didn't think they would expect to find. They thought everything would go right through. What did Rutherford hit? He hit the nucleus. He did the gold foil experiment. I would definitely write that down in your Rutherford one. He found the nucleus. He said three things about it. It is small, it is massive or dense, and it is positively charged. So he said, I don't know a lot about what these electrons are doing, but what I know is that most of the atom is empty space. Okay. Awesome. Good. Then we had this problem with electrons. Oh, before Bohr, we did have, or right around the time of Bohr, we had Chadwick. Chadwick went ahead and told us that there's a neutron in the nucleus. That's great, but he kind of fell off here. Then we had Bohr, and Bohr found this idea of orbits that said that electrons move like planets around the sun, and that there's lowest energy close to the nucleus and higher energy further away from the nucleus. Okay, so that is the history of the atom, if you will. Hopefully we're feeling good with that. Perfection. Then we move into the current model that we're working on. And the current model we're working on is called quantum mechanics. And the people that are helping shape this, Einstein's in here a little bit. There's a whole bunch of different people, but these are the 4 people that we were looking at from your notes. De Broglie said that electrons can be waves and particles at the same time, which really helped us start to shake our understanding of the electrons and think about it outside the box. Heisenberg, we had Schrodinger. He did that complex mathematical equation to say we didn't know exactly where they are. Heisenberg says you cannot know the location, where it is, and the motion, where it's going, of an electron at the same time. As soon as you know one, you don't know the other, and vice versa. Altbau's talking about the orbital charts. And remember, those are just regions of space with a high probability of finding an electron. Altbau says you fill the lowest energy level first. And then Hund says you can only put 1 electron in at any given time. Okay? So if you're feeling good with this, hopefully that will translate well into your test on Friday, because a big chunk of that test is going to be about the history of the atom. Okay? So what I'm going to do is I'm going to give you have 10 minutes remaining. I would like for you to finish filling in this worksheet. Make sure you know these elements. You have the flashcards things. Those of you at home, if you want to make flashcards, that works for me. Working on atomic structure worksheet number 3. If you would like to make sure that you know how to do that for Friday. Okay. And then the last thing that you do want to do is open up your Chromebooks. There are 3 lecture questions for today. So in the last 10 minutes here, and you guys at home, as long as I got your attendance, I don't think anybody new is here. You guys at home, if you want to log off, get your lecture questions done, make sure you do those before you walk away today. So go into the week 16 Tuesday folder and knock out those 3 lecture questions. If you don't have any questions, you guys are free to be. You guys in here, finish up those flashcards and keep working on worksheet number 3. Perfect. Thank you, guys.